Okay, so hello guys, I'm audible to everyone. So we'll start within 5 minutes. I think I'm audible to everyone, guys. If I'm audible, then please do confirm in the chat. Okay, I think I'm visible also. So please do confirm in the chat if I'm audible and visible. So can you confirm, guys? Can you confirm in the chat if my audio and video both are fine? Great. So I think everyone can hear to me and everyone can see. So let's wait for 2 more minutes and then we'll start with the session. Okay, I think we can start with the session. So, hello everyone, good afternoon to all. This is the very first session for the generative AI. From today onwards, we are going to start with a community session of generative AI. So, yes, in today's session, we'll be talking about that what all thing we are going to discuss throughout this sessions. And this session, actually, it will be happening for upcoming 2 weeks, and it will be on the same time. I'm going to take the session from 3 p.m. onwards, maybe 3 to 5. So here in this community session, we'll try to discuss many more things regarding the generative AI. So we'll start from very basic and we'll go to the advanced. There we'll try to develop different type of applications as well. First of all, I will start with the theory. So there I will discuss about the theoretical like stuff and all, that what is generative AI, what is a LLM, and after that I will like go with the OpenAI language. Don't worry, each and everything I will discuss in a very detailed way, and I will show you the dashboard as well, where all the lectures and all will be uploaded. And apart from that, I will show you the where you can find out all the videos, quizzes, and assignments and all. because along with the session I will give you the different assignment, different quizzes, so at least you can practice with the concepts. Got it, guys? Yes or no? So are you excited? Please do let me know in the chat if you are excited then. Great. So I think we can start. And so first of all, guys, what I will do, I will give you the detailed introduction of the course, that what all thing we are going to discuss in this community session. And here, basically, this is our dashboard. So let me share this link with all of you. So don't worry, my team will share the link of this dashboard in the chat. So from there, what you can do, you can enroll. It is completely free. You no need to pay anything for this community session, and all the lectures and all the assignment and quizzes will be uploaded over here. Don't worry, I will come to the curriculum also. So here, first of all, let me show you the home page. This is the home page, guys. This is the home page of this dashboard, and there like you can enroll in this particular dashboard. And don't worry, each and every video you will find out over the iNeuron YouTube channel as well. So all the recorded video and all, it will be available inside the iNeuron YouTube channel. Definitely this video is going to be recorded after the session, so this video will be available inside the iNeuron YouTube channel as well as over the dashboard. So here, guys, this is the dashboard. I think you got a link of the dashboard. So there you can enroll, and then like you can start your journey of the generative AI. So here, guys, me and Buppy both are going to take this particular session. So there we are going to discuss in depth about the generative AI, about the LLM. We'll try to discuss about various application, various recent model, LLM models and all. We have so many things to discuss about the generative AI. We have planned for the 2 weeks, but maybe more than 2 weeks. We'll try to take, if we are not able to cover and like all the curriculum, whatever we have defined, whatever we have thought, so definitely we'll be extending the date as well. But yeah, we will make sure that within 2 weeks, whatever curriculum we have defined, we'll try to complete it. So here, guys, me and Buppy. So if you don't know about me, guys, so my name is Sunny. My name is Sunny Savita. I'm working in iNeuron from past 3 years, and I'm having expertise in data science. I have explored every aspect of the data science, like machine learning, deep learning, and advanced deep learning like computer vision, NLP. I have worked with the MLOps as well. There I have designed various applications and all. Got it? So yeah, you can search me about more over the LinkedIn. There you will get got my profile, and you will get each and everything in a detailed way. So here, guys, what you need to do. So first of all, you need to enroll to this particular dashboard. You no need to pay anything over here. And if you are going to log in, after login, what you need to do. You will be redirecting to this particular dashboard. And so let me show you the dashboard first of all. This is the dashboard, guys. As of now, there is no such videos and all. Definitely after the session, we'll upload the videos and assignment and quizzes. So definitely along with the sessions and all, you can practice. So this thing is clear to all of you, yes or no? Have you enrolled through this dashboard? Did you get this dashboard? Please do confirm in the chat. I'm waiting for your reply. Please do it, guys. Great. So I can see many people are saying yes. So definitely now we can discuss about the curriculums and all. So whatever thing we are going to discuss throughout this community session. First of all, I will give you the detailed introduction of the syllabus. What all topics we have. We'll try to more focus on the recent trends. I am not going into the classical machine learning and the deep learning basically. So I will focus more focus basically on the OpenAI, LangChain and all. So don't worry, I will give you the detailed introduction of the syllabus, that whatever thing we are going to discuss inside this community session. So the first thing what you need to do, guys, you need to enroll inside this dashboard. And whatever like videos and all you will get, you will like go through, and basically you can watch it over here itself directly. Now let's discuss about the curriculum and all, that what all thing we are going to discuss. And for that, basically I have created one PPT, so let me show you that a particular PPT. Just a second. So here is a PPT, guys. Can you see this PPT? Yes or no? Please do confirm in the chat if it is visible to all of you. Great. I think this PPT is visible to all of you. Now, guys, we can discuss that what will be our like topics and all, that what all thing basically we have to discuss throughout this committee session. So here, first of all, I will start from the generative AI. So there, I will give you the detailed overview of the generative AI. That what is a generative AI, why we should use a generative AI, what all type of like application we can create, and each and everything, each and every theoretical stuff we try to discuss regarding the generative AI. And after that, after the generative AI, I will come to this large language model. So just a second, let me open my pen as well, so I can write it down each and everything. Yeah, so here guys, we can I can write it down as well now. So here, the first thing, basically, first I'm going to start from the generative AI. There, definitely I'll be talking about each and everything, each and every aspect of the generative AI. Then after that, I will come to this large language model. There, I will try to discuss this LLMs, large language model, in a very detailed way. We'll try to see the complete history of the large language model, that what is a large language model, what all types of model we have, what was the classical model, and what is a recent model. Okay, so each and everything we'll try to discuss regarding this LLMs. And after that, after completing this theoretical part, theoretical this stuff and all regarding the generative AI, regarding this LLMs, I will come to this OpenAI and this Langchain. So there, we'll try to discuss in a very detailed way that what is the OpenAI, what is the OpenAI API, and inside the OpenAI API, we have a different thing, right? So in a OpenAI itself, you will find out a various model that like OpenAI has created a various model that different version of the GPTs. Okay, so it is having some like a old model as well, some legacies and all, and some upcoming models. So each and every model will try to discuss. I will give you the walkthrough regarding those particular model, and I will discuss about the Python API, API, that how you can utilize those particular model by using the Python. Getting my point? And apart from that, apart from the Python API and all, we'll try to discuss that like if we are going to be if we are going to use the Langchain, right? So how it is different from the OpenAI. So at the first place, I will give you the detailed differences between this OpenAI and this Langchain, that how it is different to each other, that why this Langchain is required. Then I will come to the Langchain, and then again we'll try to create again basically we'll try to define the Langchain and all by using the Python. We'll try to use the Langchain different like a component of the Langchain, like memory, chains, agents and all. And yes, after that I will try to create one application. Okay, so here basically we'll try to create one application, and with that definitely we'll be able to justify the knowledge, whatever actually we are going to learn regarding this LLM, OpenAI and Langchain, by using that, by creating that particular project. And after that, I will come to the advanced part like vector databases. We'll try to discuss about different vector databases. And first of all, we'll try to discuss the need of the vector database, that why it is required, what is the meaning of the embedding, how we can save the embedding, how we can retrieve that, and how this vector database plays an important role whenever we are going to create any application related to this LLMs. Okay, so there we'll try to discuss about the vector databases, and then I will come to the some open source model. So first of all, I will come to this Llama. And I will discuss about the Llama indexes. What is the Llama index? And we have a like couple of open source model which is very famous. So we'll try to talk about those model as well. Like we have a Llama 2 itself, we have a Falcon, we have a Bloom. There are various model, and we'll show you by using those model how you can create how you can create your end-to-end application. You can solve any sort of a task. Just take a name. Don't worry. I will give you the detailed overview about the NLP and all, that what all tasks does exist, what all tasks basically we have, what all tasks we can solve by using this LLM. Each and everything we'll talk about. And then finally, we'll create one more end-to-end project. There we'll try to use the entire knowledge, whatever we are going to be learn, this vector databases, different open source model, and a LangChain, OpenAI, Llama indexes, and finally we'll try to deploy that model by using the MLOps concept. So did you like this syllabus? Yes or no? Please do let me know, guys. Please do let me know in the chat if you like this syllabus. Yes or no? The agenda is clear to all of you. If you can write it down in the chat, I think that would be great. Great. So I can see many yes in the chat, and many people are saying yes, they are able to get. Yes, don't worry. We'll give you the PPT and all. Each and everything will be there in a resource section. So from there, you can download this PPT. You can download this entire thing, whatever I will be using throughout the session. Yes, so fine. I got a confirmation. Now, the first thing, many people are asking the prerequisite. What will be the prerequisite if you are starting with this committee session? So prerequisite wise, if you have a basic knowledge of the Python, if you have a basic knowledge of the Python, if you know about the core Python, in a core Python, actually we have if else for loop and different type of data structure, and the knowledge of the database, exception handling. If you know about the basic Python, the basics of Python, then definitely you can proceed with this course. Along with that, if you have some basic knowledge about machine learning and deep learning, so you will understand the concept, basically whatever we are going to teach you in a better manner, in a better way, because here I'm not going to talk about the classical ML or the basics of the deep learning, like artificial neural networks, CNN and all. Definitely I will give you the overview about the transfer learning, fine tuning and all. But here I won't talk about the neural network and this recurrent neural network, LSTMs and all. So if you have a basic understanding of machine learning and deep learning, so definitely you will understand the concept in a very well manner. Otherwise, basic Python knowledge is fine. For creating an application, basic Python knowledge is fine. Okay, so no need to worry about it. Whatever thing actually I need to explain you, definitely I will do that in the class itself, and we'll do the live implementation. I'm not going to show you any pre-written code and all. Definitely I will write it down each and everything in front of you only. Got it? So prerequisite is clear. So prerequisite is nothing, just a Python, or I can write it down over here. Basic knowledge of ML and DL. If you know this much, then definitely you will be able to understand each and everything in a well manner. Great. So yes, we'll talk about the RAG approaches and all, each and everything. Diffusion model is there. There are some recent model in LLM. Each and everything we'll talk about, and you will be capable. So let's say if you are working in your company, or maybe you are trying to switch into the generative AI, or maybe you are fresher. In every case, right? So this community course will help you definitely. If you are going to attend every session, if you are going to learn along with me, definitely you can build anything after learning all sort of a thing. Got it? Great. So I think this introduction is clear to all of you. Now I already discussed about the dashboard and all. So I given you the walkthrough of the dashboard. So the link you can find it out inside the chat, and from there itself you can enroll. Now the syllabus is clear, dashboard is clear, each and everything is fine. So I think we can start with the introduction of generative AI and LLM, because from tomorrow's onwards, I will be like move to the practical part, and there I will be talking about the OpenAI, how to generate a OpenAI key, how to use the OpenAI API, and we'll try to understand the chat completion API, functional API, and we'll try to understand the concept of the token also, that what is a token, how many token should I use whenever we are giving any sort of a prompt, what is the different prompt template and all. There are lots of things which we need to understand. So today's session actually, it will be like completely introduction session, and in this particular session we'll talk about the generative AI and the history of the large language model. So guys, are you ready? Can I get a quick yes in the chat if you are ready? Then yeah, definitely. We'll talk about the like use cases of the generative AI and all. In today's session itself, I will like give you that particular idea, that where you can utilize this generative AI in a real time. Yes, definitely. This course content and all, whatever you are seeing over here, this one, definitely it will be available over the dashboard as well. So this is our dashboard. We'll update it over here inside the course syllabus section. So each and everything, we'll try to update in the dashboard itself. Here is a class timing and all, and I will make sure that the link also. Okay, so we are not going through, we are directly streaming over the YouTube, so directly you can join through the YouTube. So for that you just need to subscribe the channel and you will get a notification in that case. Great. So people are saying yes sir, we are ready. Great. Yeah, definitely, Vamsi. We'll try to discuss the applications and all, and I will explain you all the thing in that specific way only. Don't worry. We are going to build AI application by using the AI tools, AI based application. Great. So I got many yes in the chat. Now I think we can start uh, with the introduction of generative AI and the LLM. So guys, first of all, tell me that how many of you have started with the generative AI and all already, means you have learned something. At least you have learned the basics and all. So if you can write down the chat, so that would be great. Means you are starting from very like a scratch, or you have some sort of idea. Great. So many people are saying, so some people are saying they know about the basics, and some people are saying they're starting from the scratch. Don't worry. So basically, I will start from the scratch only. Now here, guys, you can see I have created one PPT for all of you. So let me first of all let me go through with this particular PPT, and later on what I will do, I will give you the revision by using this PPT only, and in between I will use my blackboard also for explaining you some concepts and all. So here is my blackboard. So here I will be writing down whatever basically thing I need to explain you, and in between I will be using the PPTs and all. So first of all let me go through this particular PPT, and here you can see. So I have written some sort of a name. So in the generative AI, whenever we are talking about the generative AI or a large language model, so couple of name are very famous nowadays, and in those name actually this chat GPT is a like very famous. So here I have written this chat GPT. It's a product of the OpenAI. As we know about this chat GPT, everyone knows about the chat GPT, yes or no? I think yes. Now if you're talking about this Google Bard, so it's a product of the Google. and we are talking about this Meta LLM2. So this Meta LLM2, it's a product of the Facebook. Got it, guys? Yes or no? So yes, nowadays actually everyone is using this Chat GPT, Google Bard, Meta LLM2. It's also a platform similar to this Chat GPT, where you can chat or where you can ask a specific question, which you do in a Chat GPT itself. So Meta LLM2, it's a model from the Facebook side. Now here guys, if we are talking about the generative AI or we are talking about the large language model, so in our mind, the first image which comes into the picture, that is a Chat GPT, Google Bard and Meta LLM2. Yes or no? Tell me guys. Yes. Because of that only, because of this Chat GPT, Google Bard, and the the different like whatever application you are seeing nowadays, right? So Mid Journey is one of the application, or maybe Delhi, or a different applications. So because of that only, I think you are learning this particular thing, this particular course, this generative AI course. Yes or no? Yes. So, but guys, this generative AI is having their own roots. It's not all about the Chat GPT, Google Bard, and some other application which you are seeing. Chat GPT is just an application of this generative AI. Chat GPT or this Google Bard is just an application of this like LLM, large language model. Basically, we are using this large language model in a backend, like whatever application you are seeing, like Chat GPT and all, in the backend. But apart from this, this generative AI and this LLM is having their own roots. So first of all, what I will do, I will explain you the concept of the first of all, I will start from the deep learning itself. Means I need to explain you few terms and terminology regarding this deep learning. So let me back to the blackboard. So there I will be talking about the basics of the deep learning. So within 5 to 10 minutes, I will be discussing the types of the neural network and all, and then I will directly move to the LLMs and this generative AI term. So here guys, you can see what I can do. I can draw one box over here. So this is the you can think this is what, this is the neural. Basically, if we are talking about the, okay, so first of all, let me start from the deep learning itself. So if we are talking about a deep learning, so we can divide this deep learning into three major segments. So let me write it down over here. This deep learning. So guys, this deep learning actually we can divide into three major topics. So the first topic actually, which is called artificial neural network. Artificial neural network. The second topic is called convolution neural network, CNN. The third one, basically, which is called recurrent neural network. So we have three types of the neural network, and we can divide this deep learning into this three major section. Apart from this, you will find out other topics as well. So let me write down those thing over here. So the fourth one, which I can write it down over here, that is a reinforcement learning. And the fifth one, we generally talk about it. So that is what? That is a gain. So this gain also, it comes under this generative AI. I will talk about it. I will talk about this gain. I will like give you the glimpse of this generative adversarial network, that what is this, and how the architectures look like of this gains, and why I'm saying that this gains comes into the generative AI. So if we are talking about this ANN, so let me draw the box now. So if we are talking about this ANN, so here guys, see, we have an input layer. Inside this ANN actually, what we have an input layer, and you will find out the output layer. And in between actually, in between this input and output, we have a hidden layers. So just wait. Now over here guys, see, we have an input layer and we have an output layer. Now in between actually, you will find out a hidden layers, various hidden layer. So let me write it down over here, input, and here you will find out the output. Now here, in between this input and output, you will find out of various hidden layers. So let me write it down the hidden over here. So this hidden layer actually, it is nothing, it's a hyperparameter. So we can have as many as hidden layer, we can have as many as node inside the hidden layer. We all know about the artificial neural network. I'm assuming that thing. Now if we are talking about this CNN actually, so the CNN is nothing. So in the CNN, one more thing you will find out in terms of this CNN. That is what? That is a convolution. we always perform the convolution in terms of this CNN. So here, if we are talking about this ANN, so we are using the structured data where we have like different features, numeric feature or categorical feature, and we try to solve the regression and classification related problem. But whenever we are talking about this CNN, so here the CNN actually specifically we use for the image related data, image or video related data. You can say that we use the CNN and all for the grid type of data. Okay, so we use this CNN for the grid type of data, and there you will find out one more component, that is what, that is a convolution. So here let me write it down. So the component name is what? Component name is a convolution. So in the convolution, actually, you will find out a various step. So we have a various step in the convolution itself. So the very first step which we perform, what we do, guys, tell me? We perform the feature extraction by using a different filter. After that, what we do? We perform the pooling, and then we flatten the layer. So there are different steps you will find out inside the convolution itself. And after that, what we do? We apply the fully connected layer. So that is nothing, that is my ANN itself. So over here I can write it down. We have this convolution and we have a artificial neural network. So this is my first architecture, which is which is the ANN itself, and this is my second one, that is what? That is a CNN. Now if we are talking about the third one, which is a very interesting, that is called recurrent neural network. That is called recurrent neural network. So this ANN we generally use for the structured data, where we have a numerical column or categorical column, and in the target column it will be a numeric or categorical one, and based on that basically we are going to decide whether it will be a classification problem or a regression problem. Now if we are talking about the CNN, so already I told you. If we are talking about this RNN, so the name is what? The full form of what? The full form is the recurrent neural network. So this RNN actually we are using for the sequence related data. So wherever we have a sequence, so this RNN we use for the sequence related data. Now let me do one thing. Let me draw the architecture of this RNN. So over here, guys, in the RNN, what you will find out. So let's say this is my box, and here is what? Here is my input. So this is what, guys, tell me? This is my input. Now here is what? Here is my output. So let me draw the output one more time. This is what? This is my output. Got it? Now here, guys, see, this is my input, this is my output, and this is what? This is my hidden layer. Now in the hidden layer, actually you will find out one thing, one concept, and the concept is nothing. The concept is called a feedback loop. Okay, so whatever output I'm getting from the hidden layer, actually again we are passing that output to my hidden layer until the entire timestamp. So that thing actually we learn in the RNN itself. Actually this RNN is nothing, it's a special type of a neural network, and there you will find out the feedback loop. Feedback loop means what? So whatever output we are getting from the hidden layer, again we are passing the same output to the hidden layer until we are not going to complete the entire timestamp. That is what? That is the RNN. Now we are talking about the LLM. So why I am discussing this RNN and all? Because this LLM actually somehow it is connected to this RNN itself. Before starting with the LLM, a large language model, we'll have to understand the concept of the RNN, LSTM, attention, like encoder decoder, and then attention, self-attention and all. So here I'm not going to discuss in a very detailed way. I'm just giving you the glimpse of that what is a like RNN, what is the LSTM, what was the GRU, and then what was the sequence to sequence mapping, and where this attention comes into a picture, then how they have invented the self-attention, then how they started the using this transfer learning and this fine tuning in terms of this large language model. Why we are calling it is a large language model? Why we are not calling it a model? Okay, so each and everything we'll try to discuss. Now you all know about this reinforcement learning and all. So in the reinforcement learning, you will find out one agent, environment. Regarding that particular agent, you will find out a different state. Getting my point? And then you will find out the feedback. So that actually it comes inside the reinforcement learning, and that is also part of the deep learning only. Now if we are talking about GAIN, so GAIN is nothing actually. So in the GAIN, again you will find out a neural network which we are using for generating a data, and that also comes inside the generative AI. And we have a different types of GAIN. So first of all, tell me guys, this like types of the neural network, this is clear to all of you? Please do let me know in the chat if this thing is clear. Then I will proceed with the next topic. Use cases wise, I will come to the use case and I will try to discuss a different use case. I will come to the use case, then I will tell you the applications of that, and then I will come to the domains as well. Then in what all domains you can apply those use cases. So don't worry, each and everything we'll try to discuss over here. Yes, I will directly come to the generative AI itself, but before that, I will give you the timeline. Don't worry. From tomorrow onwards, I'm going to be start. I'm going to start from the from the OpenAI itself, like complete practical and all. So no need to worry about it. So Prashad, I think you got your answer. I think this basic introduction is clear. Now, yes, coming to the generative AI only. Don't worry. Yeah, it's going to end to end. We'll try to discuss end to end thing. Don't worry about it. If you have any questions and all, so you can directly ping into the chat. So I will reply to you. Don't worry. Okay, so I think now we can proceed. So guys, here in the PPT itself, I was talking about the generative AI. Then I have given you the the types of the neural network, and I just explain you the the regarding the artificial neural network and the CNN and this RNN. So here in the generative AI, you'll find out that I have included a few slides and all. So let's try to understand a few things from here, and then again we'll go back to the blackboard, and there I will try to discuss few more concepts. So over here, we have seen the Chat GPT. Like I was talking about the different application like Chat GPT, Google Bard, and Meta LLM and all. Now let's talk about the generative AI. That what is a generative AI? Now here you can see the definition of the generative AI, which I have written over here. That is what? That is a generative AI generate new data based on a training sample, right? So the name is self-explanatory, right? So the name is explaining everything. Generative AI, the AI which is generating something. Now what all thing we can generate? So here if you are talking about the generative AI, so you can generate images, you can generate text, you can generate audios, you can generate videos. As an output you can generate anything. This image, text, audio, video, it's nothing, it's a type of the unstructured data, and definitely it is possible by using the generative AI. We can generate this type of data by using the generative AI. Now if we are talking about the generative AI, so as I told you that it is having their own roots. Okay, so it is having their own roots, and if we are going to divide this generative AI, so we can divide into two segments. So the first segment is called generative image model, and the second segment is called generative language model. And this LLM actually it falls into this particular segment, into this generative language model. Are you getting my point? Yes or no? I think yes. So if you're talking about this generative image model, so I told you when I was talking about the deep learning, like ANN, RNN, and CNN, reinforcement learning, and there was the gain. So initially we were using the gain for generating a data. So let me show you the architecture of the gain. So the how the architecture of the gain looks like. So with that you will get some sort of an idea. In the gain we are using this neural network only. So let me show you the architecture of the gain. So let me search it over here over the Google gain architecture. Now here in the image, let me open the architecture of the gain. So here guys, just see. So in the gain actually we have two main components. So the first component is a generator. This is what? This is a generator. Okay. So I think this is visible to all of you. This is what? This is a generator. And here you will find out discriminator. So this generator and discriminator is nothing. It's a neural network. So we are passing this real data. So here basically what we are going to do, we are going to pass a real data, and here we have a generator which is generating some sort of a like synthetic data, and here we have a discriminator. Based on that, we are going to discriminate between real data and the synthetic data. So this is the architecture of the game, and inside this architecture you will find out we are using two main things. We are using two main components. The first one is generator and the second component is a discriminator. I think you're getting my point. And this generator and discriminator is nothing, it's a neural network. Got it? So this is also comes under this generative AI. So now let me show you this generative AI. Now over here I have written 2 points: generative image model and generative language model. So if you're talking about generative image model, so in our previous days, in our back days actually, in our old days in 2019, 18, so this GAN was very popular for generating a data. Again, this GAN is very like expensive in terms of computation power and all. So it is very very much expensive in terms of computation. So over here you can see, so we were using this GAN. We were using this GAN for generating images and all in our back days in 2018 and in 2019, and it was very popular. And we have different variants of the GANs. If you'll find out the type of the GAN, you will find out many types. Now, recently, actually, you have find out the trend of the LLM, large language model. Now, guys, here we are talking about the GAN, and then this GAN basically it was the old concept. It is an old concept basically, and there are different variants of the GAN as well. Now, over here, if we are talking about this large language model, so it become very famous from the transformer. I will come to the transformer. I will tell you the complete history of the transformer as well. Now, this image model and this language model. But in a recent days, what I have seen in terms of this LLM and all, even we can generate the images by using this LLM. We got those LLM basically, which is like that much powerful. So by using those particular LLM, we can generate images as well. Okay, so I will show you couple of models and all regarding this like image generation, and definitely you will get some sort of idea that how the those particular LLMs is working in terms of image generation. I can give you a couple of example Delhi. So Delhi is a example. You can check over the OpenAI, which is a model which is like a famous for the image generation. Now here, if we are talking about this image model, so actually see this image model basically it was working for image to image generation, Now this generative model actually, so if we are talking about this generative model, it is working in terms of text to image generation, and text to text generation. So these two tasks definitely we can perform by using this LLM model. And this image to image generation, before we were doing it by using this GAN model in 2018 and in 2019. Now, as I told you that we have those powerful model in our recent days. By using those particular model, definitely we can implement image to image generation as well. That is also possible. So regarding that, definitely I will show you a couple of model. So we are having 4 tasks. Here I have written it. Now let me move to the next slide and let me show you that what I have. So here guys, you can see this cat is representing a generative model where you are giving a prompt, means where you are giving a question, and as a response, as an output basically you are getting a response. So in terms of, see here we are talking about the generative model. I am not talking about specifically this LLM. Okay, so I told you this generative model actually, you can think it's a superset, this generative AI. And under this generative AI, you will find out this LLM. And GAN is also part of this generative AI. Getting my point? I think this thing is getting clear. So over here, if we are talking about the generative model, so we are giving an input and we are getting a like output. Now, specifically, if I am talking about regarding this LLM, regarding this large language model, so this input actually, this is called input prompt, and the output actually it is called output prompt. So this cat you can imagine as a generative model or as a LLM model. So what we are passing as an input, we are passing input prompt, and we are getting as a output prompt. So this prompt term is a very important. I think you have heard about this prompt engineering and all that prompt engineer is getting this much, that much, and this prompt engineer plays a very important role if we have to design any sort of a prompt. Now different types of prompt, like zero shot prompt, few shot learning and all. We'll talk about it as I will progress with the like implementation and all. In between I will give you like idea regarding each and everything. Now over here, guys, you can see where this generative AI exists. So if you will look into this particular slide, so here you will find out this generative AI actually it lies inside the deep learning. Getting my point? So this generative AI actually it like reside inside the deep learning. Initially only I have explained you that we have a different types of neural network and it's a part of the deep learning only. Now whether we are going to generate images by using the LLM, by using the gains, or whether I'm going to perform text to text generation, text to image generation, or image to text generation by using the LLM, both lies inside this generative AI, and this generative AI is a part of the, it's a part of the, tell me, it's a part of the deep learning. Now over here guys, I have written a couple of more slides, so I will try to explain you, but first of all let me give you the timeline of the LLM, and then specifically I will come to the LLM and all, and I will be talking about this descriptive AI and the generative AI as well. So tell me guys, this part is clear? Are we going good? Are you able to understand whatever I am explaining to you, all of you? So if you are getting it, so please write down the chat and you can ask me the questions as well. If you have any type of doubt, or like if you're getting it or not getting it, whatever, you can ask me in the like chat section. I will reply to your questions. No, reinforcement learning is not required. Uh, Specifically we should not go for the reinforcement learning and all. Yes, this is a part of the like this generative AI is a part of the deep learning, right? Yes, LLM model used in a generative AI, correct? You got it, guys. Mathematical intuition. So we'll talk about the mathematical intuition and all, but this more this course, this community session is it is more focusing on the applied side. So I will create a various application in between. Whatever mathematical concept and all will be required, I will let you know that. Don't worry. Great. So I think people are getting it and they are trying to understand. Fine. So whatever I have explained you, let me explain you with the like blackboard. And then again I will come to this PPT and will try to wrap up the theoretical stuff. And then I will explain you the applications and all. So over here, guys, see, I was talking about this ANN, CNN, RNN, RL, and GAN. Now I started from the generative AI itself. So I have started from the generative AI, and I told you this generative AI is nothing. You can consider it as a superset, as a superset. Now inside this generative AI, you will find out many many concept, many topics and all. So here regarding the generative AI, there is two main thing which you will find out. The first one is gain, that is a generative adversarial network. The second is what? LLMs, large language model. Now we have a various tasks. So here let me write down the tasks as well. So the task wise, so here I told you the different tasks basically. So the first task which I can write it down over here, that is a image to image generation. Image to image generation. Now the second task was the image to text to text generation. Text to text generation. Text to text generation. Now the third task was the image to text generation, image to text generation, and the fourth one was the image to image generation. Sorry, text to text generation, image to text, and text to image generation. So let me write it down over here. Text to image generation. Text to image generation. Now, if we are talking about this image to image generation, yes, we were able to do this particular thing by using this GANs. We have seen the gains. Now, if we are talking about this text to text generation, yes, it was possible by using the LSTM, RNN, and by using the different model as well. But yeah, this text to text generation actually nowadays you are seeing we are preferring this large language model for this text to text generation, and this chat gpt is the biggest application, biggest like example for that, the chat gpt which we are seeing. Image to text generation, yes, this is also possible by using a different model like rnn, lstm, and gru. Image captioning, if you have heard about this image capturing task, so that is also possible by using this classical model. But yeah, by using this llm also we can perform it, we can do it. Now, if we are talking about this text to image generation, so yes, this type of task nowadays it is possible by using the LLM. So yes, LLM is able to LLM is able to perform a various amount of tasks, whether it's a homogeneous or it's a heterogeneous. Now, I was talking about the LLM. Sorry, I was talking about this generative AI. So where it exists. So this generative AI actually it exists in a like a deep learning itself. So you can think that AI is a superset, machine learning is a subset, deep learning again is a subset of the machine learning, and this generative AI is a subset of the deep learning, because as I already told you, we have a different like other neural network also in a like a deep learning, and this CNN is one of them, this convolution neural network. Okay, so I think this part is clear to all of you. Now let me draw the architecture that where this generative AI exists. So you can think this is what, this is my AI, this is one, this is the like a superset. Now here, this is what, this is my machine learning, this one. Now inside that you will find out the deep learning, and inside the deep learning you will find out this generative AI. So let me take a different color over here. Let me take this color. So here you will find out the generative AI. So this is what, this fourth circle is what, this is the generative AI. Got it? Now here you can see why we are saying, so why we are saying this is the like a subset. So I think each and every explanation I have given you over here, you can prefer this this particular slide, that why I am saying this generative AI is a subset of the deep learning. So let me write it down over here. This is what, this is nothing, this is the gen AI, and it's a subset of the deep learning. Now guys, let me explain you the timeline of the this LLM. So now you got it that this LLM is nothing, it's a part of the generative AI itself, this large language model. Now let me talk about the complete timeline of this large language model. So how it evaluate, and I can like talk about the complete history of it. And here guys, you can see that first I was talking about the RNN. So as you know that what is the RNN? Tell me. RNN is nothing, it's a type of the neural network. It's a type of the neural network. So there basically we have a feedback loop. Again, we can pass the information to our hidden layer. Now you will find out a different types of RNN or some advanced architecture in terms of this RNN itself. The second like thing which is a type of the RNN itself, that is called LSTM. LSTM. Right? So in the LSTM actually, if you are talking about this LSTM, so here you will find out the concept of the cell state. So in the RNN, we just have a timestamp, and it is for the short-term memory. It is for the short-term memory. We cannot retain a longer sentences by using this RNN. It is not possible. If our sentence is a very huge or it's a very long, so we cannot retain that particular sentence by using this RNN. But if we are talking about this LSTM, yes, we can do it by using this LSTM. So in this LSTM, you will find out the concept of the cell state. So this LSTM is nothing, it is for the short-term dependency, and it is for the long-term dependency also. It is for the like a memory, short-term memory, and it is for the long-term memory as well. If you will look into the architecture of the LSTM, so you will find out along with this time stem. So here we have the time stem, uh, it's a hidden state actually, uh, like on a different time stem. Along with that, you will find out one cell state. So it is going to retain the long-term dependency. And in between, in this time stamp, in this short-term memory, and in this cell state, you will find out a connection. The connection in terms of gates. So here you will find out one connection, one gate basically, that is called forget gate. So here I can write down the forget gate. Now here you will find out one more gate actually. So that is called input gate. Here you are passing the input. Now here you will find out one more gate over here, that is called output gate. Output gate. Okay, so we have three gates inside the LSTM for sustaining a long-term dependency or for reminding a long sentences. Now, you will find out one more updated version of the LSTM. So this RNN is an old thing. This LSTM is also an old thing. Now you will find out one more updated version of the LSTM. That is what? That is a GRU. So this GRU actually they have invented in 2014, and they took the inspiration from the LSTM itself. Now inside this GRU, you won't find out the concept of the cell state. Everything is being done by the hidden state itself. And here basically in the GRU, we just have two gate, update gate, sorry, reset gate and update gate. And it's a advanced or you can say it's a updation on top of this LSTM. It's an updated version of the like LSTM itself. Now what is the full form of the GRU? Gate and recurrent unit. Now over here guys, see, this was the three architecture which was very famous during 2018 and 19 in our old days. Now here see, one concept comes into the picture. If we are talking about this RNN, LSTM and GRU, so by using this particular architecture, what we are doing? So by using this particular architecture, we are going to process a sequence data. Yes or no? We are going to process a sequence data. Now here one concept comes into a picture, sequence to sequence mapping, and for that only we are using this particular architecture. So we have a different type of like a mapping technique. So let me write it down over here, different type of mapping technique. Now it is fine. I think I am audible to everyone now. Now I am audible, guys. Please do confirm in the chat. I think there were the issue from the mic side. Now I am audible, so please do confirm in the chat if I am audible then. And is there any echo or what? So, guys, are you facing any echo in my voice? Now it is fine. Yeah, it is perfect, I think. Great, fine. It's clear. Great. I think now I am audible to everyone. Sorry, I think there was a issue from the. Do let me know in the chat from where I lost my voice. So this concept is clear. This one to many or one to one to many to one, many to many. Yeah, so I think I was there, RNN, LSTM and GRU. Now I think it is fine, I am audible to everyone. Great, so I was talking about RNN, LSTM, GRU and then I talked about the different mapping sequences. Now this mapping sequences actually we can implement by using this RNN, LSTM and GRU. So over here, yes, so one to many to one, many to many, RNN, LSTM and GRU. This was the sequences actually I was talking about. Now in 2014 actually, see, this was the sequences by we can implement by using this different models. Getting my point? Now over here, if we are talking about this particular sequences, definitely we can we can create a various application by using this model. But here basically we are having some sort of a restriction. As I told you, the different application like one to many to one. So many to one means you can think that sentiment analysis. One to many means what? One to many you can say image capturing. Many to many image language translation. So there are various application of this sequences. Now see, if we are talking about the sequences, the sequence to sequence mapping. Now we can definitely implement it by using this particular architecture. So the problem we were having, the problem was actually we cannot see, let's say we are giving an input. In the input actually we have a 5 words. So whatever output we'll be getting, in the output also we should have a 5 words. So it's a fixed length input and output. Getting my point, what I'm saying? So by using this particular mapping, one to one, many to one, or like many to many, specifically we are talking about many to many. So there was some problem, there was some issue. The issue was fixed length input and output. So whatever number of inputs we are passing, in terms of this many to many I'm talking about, okay, so whatever number of inputs we are passing, so those many output only we can get it over here in the output itself. So here actually one research paper came into the picture in 2014. You can search about the research paper, sequence to sequence learning. So inside that paper, they have introduced the concept of the encoder and decoder. In the encoder and decoder, actually, the one segment was the encoder segment. So let me draw it over here. So the one segment was the encoder segment, and the another segment was the decoder segment. This another segment was the decoder segment, and in between actually, we were having the context vector. So here in between this encoder, so we are having the encoder, and we are having the decoder. One part was the encoder and one part was the decoder, and in between we are having the context vector. Means whatever information was there from encoder to decoder, we were passing through this context vector. Means we were wrapping all the information in this context vector and we were passing to the decoder. That actually the paper has been published in 2014. You can search about it. You can search over the Google, sequence to sequence learning. So let me search in front of you only. Now over here I can write it down, sequence to sequence learning research paper. Now over here guys, you will find out this particular research paper. Now just try to read this paper. Now here in this particular paper, they have clarified the issue, that what was the issue with the classical mapping. So that was restricted to the input and output. Now over here, if you will read this particular research paper, so easily you can find it out the issue. Here itself in the introduction itself, they have mentioned this. Despite their flexibility and power, can only be applied problem whose inputs and targets can be sensibly encoded with a vector of fixed dimensionality. It was just for the fixed dimensionality, and basically we were having a limitations. So for solving that particular limitation, this sequence to sequence learning paper came into the picture, and there was 3 person, Ilya Susker and Oriol, and this there was one more person, and this paper from the Google site. Now here guys, let me open this blackboard again. So there was a context vector, but this encoder and decoder also was not able to perform well for the longer sentences. So here in the research, basically they have proved if my sentence is going like above from 30 to 50 words, right? If it is longer than 30 to 50 words, so in that case it was not able to sustain the context. It was not able to sustain the context if we are using this encoder decoder architecture. Now you will ask me, Sunny, what we were having inside the encoder and decoder? So we are talking about the encoder. So again here we were using the either RNN, LSTM or LSTM, and we were using this GRU. And here also in the decoder also we are using this RNN, we are using the LSTM, and we were using this GRU. Got it? I think you got the problem now, and you got to know about the encoder and decoder. So we have started from the RNN, then now we came to the LSTM, GRU, and then we have a different mapping. And for solving this particular issue, which is related to this many to many mapping, many to many sequence mapping, and this language translation is one of the example. If you will search over the Google Translate, just search over there anything. Let's say in Hindi you are saying that मेरा नाम Sunny है or मेरा नाम whatsoever. So it will generate an output. So this input word and output word will be a mismatch. But that was a restriction with this with the classical mapping. So for using this encoder and decoder architecture, we can solve that particular problem. Now here also we are having the issue that we cannot proceed a longer sentences. We cannot proceed a longer sentences. So here one more concept comes into a picture inside this context itself, and that was the attention. That was the attention. So here neural translation with just a second, let me search about the neural translation with attention. Yes, this was the paper, and this was the first paper. Let me search about the research paper. Yeah. Now guys, this was the paper. In this particular paper, they have introduced the concept of the attention, and just try to download it. You need to download this particular paper, and then you can see there. So just a second, let me show you this paper as well. And this is the main main papers basically which you will find out while you will be learning this deep learning and all. So this paper actually this has been introduced in 2015. I think in 2015 or 16. Now here they have introduced the concept of the attention actually. So just try to read this particular paper, at least try to read the introduction of it, There they have defined that what was the problem with the encoder and decoder, and where this attention comes into the picture, and what is the actual meaning of the attention. They have introduced each and everything over here inside this particular paper. Inside this particular paper, they have introduced each and everything regarding the attention. See, this is the architecture of the attention model. And before going through with any blog, any website or any tutorial, try to go through with the research paper and try to understand the motive of that research paper. Now see guys, here I'm not going into the detail of the attention, because this attention itself is a longer topic, but I can like give you the glimpse of that what they were doing in the attention. So they were mapping. So let's say we have a 5 words in the sentence, so they were trying to map each word, whatever word we have an input, we were trying to match each input word with the output word. Means this input and output, this encoder and decoder. If we are talking about this decoder actually, so this is having the information, each and every information of the hidden state, whatever like in the encoder, like you will find out this RNN, LSTM, or whether it's a GRU. So we have a hidden state actually, right? So this decoder part is having the information regarding those particular hidden state, all the hidden state, and because of that it was able to predict. So whatever like sentence and whatever words or longer sentences, or like the longer sentences and all, which whatever basically we are passing, it was able to predict, okay, so this word is related to that particular sentence. So what I will do, I will create a like one dedicated video on top of it. There I will try to discuss this attention mechanism. But yeah, here I'm just giving you the timeline, and with that you can clearly understand. So here we were having the attention mechanism. Now guys, by using this attention mechanism, in 2018, Google published one research paper, and the research paper name was Attention about this encoder. In the encoder and this decoder, we were using, what we were using guys, tell me? We were using this LSTM. Either we were using the LSTM, RNN, or maybe GRU. Now there also we are having the LSTM, maybe RNN, or maybe we are having the GRU. And if we are talking about the attention, so whatever information we are passing from here to here, so you are having the context vector. Now on top of that, we are having the attention layer, and it was nothing, it was just a mapping from input words to output word. Now here actually they have published one paper in 2018, and the paper name was Attention All Your Need. Now this paper actually, it was a breakthrough in the NLP history. This paper has been published in 2018, and here actually decoder. But there is one thing basically in terms of this encoder and decoder. You won't be able to find out this LSTM, RNN and GRU. They are not using any RNN cell, any LSTM cell, or any GRU cell. So here actually they were using something else. And here what is the name of the research paper? So they were saying that attention all your need, only attention is required for generating us, let's say we are passing any sort of an input, means any longer input. So from that particular input, only attention is required for generating an output. Now how? Let me show you that. This transformer architecture, or let me show you the attention all your need research paper. So attention all your need research paper. So guys, this is a very prestigious paper in our NLP history, and this changed the complete history of the NLP and whatever LLM and all, whatever you are seeing like nowadays. So they have used this transformer architecture as a base model. I will come to that, and there I will try to discuss that what is the encoder and decoder. Again, I am not going into the depth of the mathematics, but yeah, definitely I will try to give you some sort of a glimpse. So over here, let me zoom in first of all this paper, and here guys, the paper name was Attention is All Your Need. So this was the researcher Ashish, Noam, Nikki, Jacob. You can search about these particular people, and here is the abstract you can see, and this is the introduction. at least try to read the introduction, try to read this particular background and the model architecture. So this was the model architecture which has been introduced by the Google researcher, and the architecture basically which you will find out inside this research paper. I think everywhere you will find out this particular architecture in whatever NLP tutorial, or if you are going to understand the attention mechanism and all. So this is the architecture. Now in this particular architecture, let's try to understand that what all things we have. So see, first of all we have an input. Okay, try to understand, try to focus over here. So we have an input over here, then we have an input embedding. So this is my first thing, input, and this is what? This is the input embedding. The third thing which we have, that is a positional encoding. Getting my point? And then after that you will find out the multi-headed attention. Then we have a normalization and all, and then we have a feed forward network. Now guys, just tell me, this is what? This is a encoder part. This is what? This is the encoder part. And this is what, guys? This is the decoder part. This is the decoder part. Getting my point? So here also we have a two segment. First was the encoder and the second was the decoder. But here we are not using any RNN cell, LSTM cell, or maybe GRU cell. Here actually we are using something else, some other concept. And the concept actually, I think this is not a new thing for you. This embedding and all, this embedding, attention, already I talked about the attention, that what it is. Mathematically it is having a some different explanation, but yeah, I think you got to know the idea. Now here we have a feed forward neural network. You know, like what is a artificial neural network, what is a feed forward neural network. So it's not a new thing for all of you. And by assembling all those things, they have created one cell, one architecture, and the name is called this transformer. So this architecture itself is called a transformer. What is this, guys? Tell me. This is a transformer. Now here, guys, just see this transformer. If we are talking about this transformer and all, so let me tell you few things regarding this transformer. So first of all, guys, this is the fast compared to the classical architecture. If we are talking about this RNN, LSTM and all, so there we are passing the input based on a time stem. But if we are talking about this transformer, guys, so here what is the importance, or what is the plus point which we have inside the transformer? It is a faster. Why? Because we can pass the input in a parallel manner. We can pass all the inputs, all the tokens in a parallel manner. Parallelly actually we can pass the input. Now over here, see, we have an input embedding. We are doing an embedding over here, and then we have a positional encoding. Means we are arranging a sequence of the sentence. Then we have a multi-headed attention. Again we are trying to figure out the meaning. See, let's say the sentence is what? I am Sunny. Now here it is trying to find out the relation I with am and Sunny. It is trying to find out the relation am with this I and Sunny. It is trying to find out a relation this Sunny and this am and this I. So it is trying to find out a relation with each and every word. So it is doing the same thing inside the multi-headed attention. Then you will find out this feed forward network, neural network actually. And yes, this is what? This is my encoder part. As I told you, this is what? This is my encoder part. Now if you will look into the decoder side, so again we have a same thing. So here we have a output embedding. Means in whatever a sequence in whatever embedded format I want output. So that is this particular thing, this output embedding. And then again we have a multi-headed attention, and we are passing this thing to the next one, to the next layer. And again we have a feed forward neural network over here. On top of this you will find out the softmax, and finally we are getting a output probability. So don't worry, I will try to discuss this transformer architecture mathematically in a detailed way in some other video. But as of now, I'm just giving you the glimpse, because whatever LLMs we are going to discuss, okay, as a base architecture, they are using this transformer. So guys, till here everything is fine, everything is clear. Please do let me know in the chat, yes or no. Yes, you can let me know in the chat. Then I will proceed with the PPT and all, and we'll try to wrap up the introduction of this LLM and all. And in tomorrow's session, we'll try to talk about the OpenAI, and we'll discuss about the OpenAI API and all, and different models of the OpenAI. Any doubt, anything? So if you have any sort of a doubt, please do let me know, guys. Please do let me know in the chat. I will try to clarify that those doubt. And so did you get a timeline of the LLM? I will come to the LLM now, the specific word. And after deep learning and NLP, what is the topic for generative AI? Please give up. So after the deep learning and see, after the transformer, actually by using this particular transformer, people has created a different LLMs and all, large language model. Now I will come to that by using the slide. I will try to show you that. I think this is pretty much clear. Now let me go back to this notes, and here you can see. So I started from the deep learning, then generative AI and all. Then you got to know that where generative AI lies. Then RNN, LSTM, GRU, different mapping, encoder, decoder, attention, and finally attention, all you need. Now let's try to understand like rest of the thing by using the slide. So here, guys, one more thing. I think we were trying to understand this particular part where this generative AI exists, and I hope you got a clear-cut idea. Now let me go back to the let me like come to the next slide. So in this slide you can see I'm talking about the generative versus discriminative model. So what is the difference between this generative and discriminative model? So we are talking about this discriminative model. So whatever you have learned so far in a classical machine learning and deep learning. So let's say I'm talking about this any classification based model. Let's say I'm talking about this RNN. So here actually see, you are training your model on a specific data. So this is your data, this is your input, and here is your output. What you are doing, guys, tell me? You are performing a supervised learning. You are performing a supervised learning by using this recurrent neural network. There is a classical model, or we have like other classical model and all. You can use any like a machine learning based model as well, like naive Bayes and different variants of the naive Bayes, or maybe some other model. You can use that particular model also. So over here we have a model, and we are going to train this model by using the supervised machine learning. There we are going to pass a specific type of data to this particular model, and here we have a different output, like a rock, this music is belong to the rock music, classical music, or maybe romantic. So here we are passing this music to my model, and finally it is going to predict something like that. This is the descriptive model. Now if we are talking about a generative model, so this is a little different compared to this discriminative model. How it is different compared to this discriminative model? So here, guys, see, we are training this. See, first of all, if we are talking about this generative model, so the training process is a little different. If we are talking about the large language model, if we are talking about the LLMs, so the process of training this LLMs is a little different compared to this discriminative model. Now over here we are talking this generative model basically. So we are passing the input to this generative model, and we are getting an output. How? So here basically we have a different step for like training this generative model. So gain wise, I already told you that what is the like process if you want to like train any gain model. If we are talking about LLM, large language model, so at the first place there will be a unsupervised learning. Then at the second place we'll be having a supervised fine tuning, and at the third place basically we have a reinforcement learning. They have recently used inside the chat in the GPT model itself, which we are using for the chat GPT. But before that, whatever LLM model they have trained on a large amount of data. So for that, first they have performed the unsupervised learning, and then they have performed the supervised fine tuning. So because of that model were able to understand each and every pattern which was there inside the data, and because of that it was able to generate the output. So this generative model is nothing in that basically we have a data. On top of that particular data we are training a model, and for that we have a various step, and basically then only we are going to do a prediction. So what it is giving me as a prediction, so whatever input we are passing, so that input it is taking, and finally it is generating the output related to that particular input. Means it is generating a new data. Getting my point? I think this part is clear to all of you. How this generative model is different from this discriminative model. Discriminative model is a classical model like supervised learning. We are performing the supervised learning now, right? So here we are having the RNN and we are passing a data and all, and we are trying to train it. Generative model, various steps we have like for the training and all, and it is responsible for generating a new data. That's it. So I hope guys this thing is clear to all of you. Now I have kept a couple of more slides regarding this particular concept. Just try to note down the headings and all, and try to remind this particular thing, this discriminative versus generative model and all. Now here the same thing, unsupervised, supervised learning, which is related to this discriminative model. Got it? And here you can see this is the generative like model. So in the generative model, what we do, first we perform the unsupervised learning, we are doing a grouping and all, and then we perform the supervised fine tuning, supervised learning. So that is the like process for training a like any sort of a LLM model, which comes under inside the generative AI itself. And gain wise, I already talked about it. Now here actually we're going to talk about this LLM. So let me give you the quick idea about this LLM and all. That is what? That is a large language model. So for that also I have created one slide, and there specifically I kept the thing related to this LLMs only. So let me start from the very first slide. Let me give you the overview, and from tomorrow, actually in tomorrow's session, I will give you the detailed like overview with respect to different models and all, whatever we have. As of now, just a quick introduction. Now, what is a LLM? So LLM is nothing. It's a model. It's a large language model which is trained it's a large language model which has been on a huge amount of data, and it is behaving like it is generating something, right? So actually by using this LLM, we can generate any like a sort of a data like text data or maybe image data, and that is a like that is the advantage, or that is a like one very famous thing regarding this LLM and all. Now if we are talking about this, why this is called LLM, why this is called large language model. So here guys, if we are talking about this large language model, so because of the size and the complexity, so here specifically I have mentioned regarding this large language model, regarding this LLM, why this is called this large language model. So here, because of the size and because of the complexity of the neural network neural network as well as the size of the data set which has been which is trained on actually this is trained on the huge amounts of data. Because of that only actually it is called a large language model. So here if we are talking about this large language model, so actually before we were not having the huge amount of data. So recently actually this data generation and all, big data actually came into the picture, and this companies and all generated a huge amount of data, and this Google, Facebook and the other companies is having a huge amount of data. So they are able to like find actually they have gathered that particular data, and on top of that data they have like as I told you, they have performed the unsupervised learning and all, and they have categorized a data, and they have provided to a different model which like has been created like GPT bot and all. And because of that like they were able to predict the next sentence, and that is the like a main advantage of this large language model. Now over here you will find out, so in the next slide I have mentioned that what makes LLM so powerful. So here, by using one single model, by using one single LLM, actually we can perform a different type of task like text generation, chatbot. We can create a chatbot also. We can do the summarization, translation, code generation. By using a single LLM, we can do that particular thing. Now here, if you will find out, so already I told you that what is the base architecture of the LLM. So here this transformer is what? It's a base architecture behind this LLM, behind this large language model. And I have already explained you the concept of the transformer, that what we having inside the transformer. Now here guys, this is a few milestone which we have in terms of the LLM. Like BERT is there. I think you know about the BERT. If we are talking about the like a back days, right, or old days in 2018, 19 or 20. when ChatGPT was not there. This GPT was not there. GPT 3.5 and all, the recent model which we are using instead of ChatGPT. So there were few milestones, and we were using this thing in our old days. Like BERT was there, GPT. Actually, GPT is having a different variant. It is having a complete family. GPT 1, 2, 3, and 3.5. Recently, GPT 4 came into the picture, and other variants as well. So XLM is also there, cross-lingual language model pre-training by this particular guy. Now T5 was also there. This is text-to-text transformer, and it was created by the Google. Now Megatron was also there. So Megatron, actually it was created by the Nvidia. Now M2M was there. So it was the part of the Facebook research. So there were many there was the many model actually. Okay, and this was the milestone in in terms of this large language model. Now over here, guys, see this BERT, GPT, XLM, T5, they are using a base architecture as a transformer one only. Now if you will see in the next slide, so I have categorized this thing. So they are using a base architecture as a transformer one only, but in that you will find out some of the model are using a encoder, and some of the model are using a decoder, and some of the model are using both encoder and decoder. Now here I have categorized this particular thing, that this is the model like BERT, Roberta, XLM, Albert, Electra, DBERTA. So these are the model, they are just using the encoder only. And if we are talking about this decoder, if we are talking about the GPT, GPT-2, GPT-3, GPT new, or like the entire family of the GPT, so they are using this decoder. So we have a two segment of the transformer architecture. Few models they are using a encoder part, and few model basically they are using a decoder. And here, guys, you will find out some model which are using both encoder as well as decoder. So this T5, BART, M2M100, Big Bird. So these are the model, actually they are using both encoder and decoder. In the transformer architecture, if you will find out, we have a two segment. So this segment, basically this one is called an encoder segment, and this particular segment, this is called a decoder segment. So here I think you got to know the idea that this is the this is the encoder segment, and this is the decoder segment. And this model, this T5, BART, M2M and Big Bird, they are using both, and we have other models as well. I just written this couple of name over here. Now apart from this, you will find out some OpenAI based model, OpenAI based LLM model. So GPT-4 is there, GPT 3.5 is there, GPT base is there, DALL-E, Whisper, embeddings. Okay, so these are the different model which you will find out over the OpenAI website itself. And here definitely GPT is one of the prestigious model, or this is one of the very important model which people are using nowadays for creating their applications and all, and it can perform any sort of a task related to a generation. Okay, now over here this is the OpenAI based model which I have written. Now apart from this, you will find out other open source model. So this is the model from the OpenAI side. So if you are going to hit this model, so definitely OpenAI is going to charge you regarding the tokens, regarding like how many tokens and all, whatever you are using. According to that, it is going to charge you. But here we have some couple of open source model as well, and I have written the name like Bloom, Llama 2, Palm, Falcon, Cloudy, MPT, okay, Stable LM, and so on. We have a various model, various open source model, and yes. But I will show you that how you can use this particular model if you are going to create your application. So definitely I will let you know, I will show you that how you can utilize this model as well. I will show you the use of the Falcon. I will show you the use of the Llama 2. If you don't want to use this GPT 3.5, GPT 3.5 Turbo, I will show you the use of this Llama and this Falcon and some other open source model as well. I think you are getting my point. Now here if we are talking about what can LLM be used for. So if we are talking about LLM, that what it can do. So it can we can use this LLM for any sort of a task like classification, text generation, summarization, chatbot question answering, or maybe speech recognition, speech identification, spelling corrector. So this LLM actually, if we are talking about this LLM, so first of all, it's a model, it's a large model, it's a language model, and it's a large model. It's a large language model, And what is the what we can do by using this large language model? We can generate the data. Okay, it can identify the pattern of the data. It is having that that much of capacity, so it can identify the pattern from the data, and by using those pattern we can perform a various amount of tasks. Okay, that's why this LLM is too much powerful, and here we can use this LLM for any sort of a task. And yes, we know about this and already I have I explain you this thing. I hope this introduction is clear to all of you. Now coming to this prompt design. So prompt design and all, definitely I will talk about it once I will come to this OpenAI API. There we'll try to hit the different models of the OpenAI, and we have a different type of prompts. So as of now you can think that the prompt is nothing. Whatever input we are passing to the model, that is called input prompt, and whatever output we are getting from the model itself, that is called a output prompt. And here how ChatGPT was trained. So generative pre-training, full supervised fine-tuning, and this reinforcement learning. There was 3 steps which I have mentioned. So I will be talking about this also, and not in today's session, in the next session I'll be talking about this how ChatGPT and all it was trained. Okay, now what I can do, so over here guys, I think we should conclude the session. So how was the session? Please do let me know in the chat. It was good, bad, or what so? Did you understood everything? Did you understand everything whatever I have explained you regarding this LLM and this generative AI, the complete introduction? Because I want that before starting with any sort of a practical, the basics should be clear. Everything, did you understand? Amazing, great. How to do what is the topic? Yes. Fine. If you have any doubt and all, so you can ask me. I will try to answer for that. Now, before concluding with before concluding the session, let me show you a few more things over here. So see, here first of all, what you need to do. First of all, you need to go through with the OpenAI, and you need to generate a OpenAI API and all. So that basically, don't worry, I will show you while I will be doing a practical and all. So you need to at least you need to create an account, and you need to log in it over here. So once you will log in guys, here you will get 2 options. First is ChatGPT and the second is API. Just go through with this API and generate this API key. Generate the API key from here. Don't worry, in the next session, in the next class, again I will show you this thing. And here I see we have a different model. So let me show you those model, and whatever open source model and all is there, so you will find out over the Hugging Face. So let me show you the Hugging Face models, Hugging Face hub, and here you will find out the model hub. So guys, here actually we have a model hub. Just a second. Yeah, models. Now you will find out a different type of model. See, these are the models which is a open source, and you will find a complete description. Let's say this if we are talking about this Orca 2, so this updated 12 days ago, and it's a recent LLM model which has been published by the Microsoft. Now over here you can see, so it you will find out the complete description or complete detail regarding this model, and how to use it, and each and everything basically definitely we'll talk about it. Now for what all tasks basically we can use it. Okay, so according to that also you can select the models. So just go through with the Hugging Face models, and there you will find out many a different models. Okay, and yes, for sure OpenAI is also having different LLM model. So we'll talk about that. We'll try to understand the concept of this. We'll try to understand this assistant actually, and we'll try to understand the chat actually. So what is this, and how to use it, how to use this chat option and this assistant option. And here if you will go inside the documentation, so you will find out the different models over here. This GPT 3.5, DALL-E, TTS, Whisper, embedding, moderation, GPT base, GPT-3, right? Different models we have, and apart from that you can find out the different tasks. According to that also they have given you the model. So text generation, so they have given you the complete code and all. So just try to visit it, just try to go through it by yourself. Now we have other platform as well. So if you are not going to use the maybe chat, if you don't want to use this GPT and all, so here I can show you one more like option. So AI 21, okay, so AI 21 labs, AI 21 labs. So this is the recently I figured it out. Actually this is the like alternative of the GPT. So we'll talk about this also. If you don't want to pay to this, if you don't want to pay for the GPT, so you can use this AI 21 lab, and it will give you the like a one model, one LLM model. So you can use it freely. Actually it gives you the $90 credit. So yes, I will show you how you can use this AI 21 lab. So let me show you the documentation, and let me show you the models as well. So here you will find out the model basically which is there. So Jurassic 2 is a model, and it's like a pretty amazing model. And yes, definitely I'll be talking about it. And along with that, the applications of it, which is very much required, that for what all tasks we can use it, whether if you are going to create a chat bot, or maybe if you are going to do a question answering or text generation, or like sentiment analysis, for what type of task we should use it, and how to design a prompt and all regarding the specific task. Got it? So we'll talk about this also. So yes, many things is there, and definitely like from tomorrow onwards I'm going to start from the OpenAI lecture, and step by step I will come to the different models and all. So I hope guys this is clear. Yes, practical implementation will be there, don't worry. Yes, recording will be available over the YouTube. Yes, all the topic will be covered in the upcoming session, all the discussed topic and all. Yes, definitely this will be available in the dashboard. You can go and check your dashboard. This video, along with the video, you will find out the assignment, you will find out the quizzes, and regarding the particular topic. Fine, I think we can conclude the session now. Is generative AI and LLM are also used in computer vision based project. So for computer vision based project, we have a like others model. We have a different models because the task is different over there. So the task wise, we are talking about the computer vision related tasks like object detection, object segmentation, tracking, OCR, object classification. And for that we have a different model, and definitely we can use the transfer learning or fine tuning over there. Now by using this LLM, this LLM is for the like a different task. It is related to the language related task. It is not related to that detection or a segmentation or a tracking. It is not related to that particular task. It is related to the language related task. And here see, let me show you one more paper, one more research paper. So here I can show you this ULM fit. Now see, so just try to go through with this particular paper, universal language model fine tuning for text classification. Now here in this particular paper you will find out that, see, this if you know the deep learning, so in the deep learning we have two major concepts. So the one concept is called transfer learning. The second concept is called fine tuning. Transfer learning means what? So you are transferring the information from one state to another state. Okay, or like I can give you very simple example for that. Let's say you know like how to write the cycle. So for you if you know how to write the cycle, then definitely you can use that information and you can write the motorcycle also. So that is the same thing basically which we do inside the transfer learning. Let's say we have trained the model, let's say we are talking about the computer vision. So inside that you will find out we have a various tasks like detection, classification, and tracking and all. So let's talk about the model. Let's say YOLO. So or we have other model also like faster RCN and all, SSD and all, like a different model related to a detection. So their model already has been trained on some sort of a data, some amount of data, on some benchmark data. So by using that particular information, we can like perform the detection and all for our specific task. If we are not able to do it, then definitely I will fine tune my model. But how we can use the same thing in NLP? Because in NLP actually we have a task. The task is very specified. We have a specific task. Let's say we are talking about if we are talking about a task, let's say NER, name entity recognition, or let's say we are talking about the task, let's say language translation, language translation language translation, or maybe sentiment analysis. So these are the specific tasks. Specific task means regarding to the specific topic. Let's say if I want to do a sentiment analysis, so not for the entire data whatever there in the world, for the specific let's say for the Twitter data only, means whatever tweets and all we are getting. Now if we are giving any other data, any other like a task related data, so it won't be able to perform that. So actually in this particular paper you will find out that how we can use this language model for like for the universal task, and there only this LLMs comes into a picture. This LLM actually it came from the language model itself. Okay, because we are training this language model on a huge amount of data, that is why it is called LLM, large language model, because we have trained this data on a huge amount of we have trained this model on a huge amount of data. Got it? So here in this particular paper they have like shown you that how to use this transfer learning, because in before 2018 actually we were using this transfer learning in the computer vision only, in the in a different tasks of the computer vision, like object detection or segmentation. If you find out the ImageNet data, so on top of that data we have trained like a Benny model, and directly like VGG or RSNet and all, and directly we are using those particular model for our other tasks. So here if we are talking about the NLP, so we are not able to do it before this transformer and all. So actually see, we got a transformer, we got this particular concept, like how we can use this transfer learning and all in that like NLP field. So this two concept came together, transfer learning and the architecture like transformer, self attention and all, and from there itself this LLM came into the picture. LLM means large language model which has been trained on a huge amount of data, which is able to perform the transfer learning, and we can do it, we can fine tune it also. And the main the main cap is, or the main role of the LLM is what? It is able to generate a text generation. Got it? So fine, I think we are done with the session now. So rest of the thing we'll try to discuss in the tomorrow session, and we'll try to more focus on the practical side. So all the recordings and all, it will be updated on a dashboard, and yeah, that is it. The next session will be tomorrow at 3 o'clock at the same time, 3 to 4:30. Thank you. Bye bye. Take care, guys. Have a great day. And again, we'll meet tomorrow. Thank you.